Hey class, Miss Anderson here. This video is going to be for amplitude and period of trig functions. All right, so here's the original 6. We're going to just go through and look at the amplitude and period of each. So sine and cosine both have a amplitude of +1, and then they have a period of 2 pi, which means that their cycle starts to repeat. The pattern starts to repeat after a full 2 pi or 1 full revolution. And that's the same for cosine as well. For the other 4, they don't technically have an amplitude. The a value is used a little bit differently in tangent and cotangent. So in tangent and cotangent, you have a value of 1, but it's not considered an amplitude because an amplitude is defined to be like the height of the wave. So we have the height of the wave is equal to 1 for sine and cosine. But tangent, cotangent, the other ones don't really have wavelengths, so technically they don't have what we call amplitudes. So you still have an a value, and we'll get into how the a changes the graphs in a second. But the other difference between the two, for tangent and cotangent, they have a period of pi instead of 2 pi. They complete 1 full cycle in 1 pi. So it only takes half of the rotation to start repeating. And then secant and cosine, again, or cosecant and secant don't have amplitudes. They do have a values still, and we'll talk about how that can change. But their periods are going to be 2 pi still. So they do still have the same period as their original function. Okay, so let's change up the values a little bit to see how the graphs are affected. So I'm looking at each of these calculator windows were set between -2 pi radians and +2 pi radians. So 2 full cycles. So you can see, 2 full cycles of each. So the first one is our original sine function. So this is with an amplitude of 1. So your a is 1, and then a period of 2 pi. So now you can see in this one, I've changed my amplitude to 2. The amplitude of 2 changes the height of the wave. So now I have a taller wave. Notice that it didn't affect my wavelengths at all. The first wave still ended at the second mark here halfway. It just affected the height. So when a is greater than 1, we call that a vertical stretch, is our function transformation. And in sine and cosine, it's also known as the amplitude is increased to 2. In our next one, we changed the b value, so what's inside the function, to 2. And so now you can see it's actually the period that's affected. We have 1 full cycle is like up and then down. Now you can see a full cycle is up and down. It occurs in half the amount of time. So here half the cycle occurred at pi over 2, or at pi. Now the full cycle is done at pi. So it's increasing the wave speeds essentially. So now you have 2 full cycles in 1 period as before. So this one increases, it doubles. It essentially doubles the waves, or it decreases the cycle. So this one has a period of pi now instead of just 2 pi. So here we have 1/2 out in front of a, and you can see how that one changes. The wavelength, or the wave height, is smaller. So again, it reduced the wave height. So this one, since a is between 1 and 0, it would have a vertical shrink, and your amplitude would be 1/2. So like the waves aren't quite as tall, but the 1/2 out front doesn't change the time it takes to complete 1 full cycle. But if you put the half inside for the b value, you can see that now instead of completing 1 full cycle in 2 pi, you are only completing half of a cycle in 2 pi. So this 1/2 decreases that wavelength speed. And then if you put it together, so you put a 3, it's going to increase the height It's going to be a height of 3, and then the 2 is going to make it have 2 full cycles of the original 1 period. So it changes the period. So in general, if you're looking at sine or cosine or cosecant and secant, A affects the amplitude for sine and cosine. And it is technically a vertical stretch for all of them, or a vertical shrink. It's a vertical stretch when A is greater than 1. It's a vertical shrink when A is between 0 and 1, so a fraction. And then your amplitude is always defined as the absolute value of A, so your amplitude you never define it as to be negative. If you happen to have a negative value for your A, that means that your graph is reflected across your x-axis. So if you had a negative sine function, the original sine function looked like this. The negative sine function would be a reflection of that. So you would have a reflection. B affects the period of the graph. In general, your period is 2 pi. If you have a b value other than 1, you take 2 pi divided by b to figure out your period. And then that is where, so 2 pi over b is where 1 full cycle will end. If b is less than 0, so if your b happens to be negative, then you end up with a reflection over the y-axis. We're not actually going to see that very often in this class. In general, for tangent and cotangent, these ones are a little bit different. Tangent and cotangent, we do not refer to as an amplitude because we don't have a height of a wave. So instead, the A is just affects the vertical transformations. If your A value is greater than 1, you're going to have a vertical stretch. And if A is between 0 and 1, you're going to have a vertical shrink. So for example, the tangent function typically looks like this. If it's stretched, it's going to be like your slope is going to be a little bit more, rise a little bit faster. And then if it has a vertical shrink, it's going to be less steep, so it might rise a little bit slower. So that's how A can affect it, vertical stretch, vertical shrink. And then if A is negative, then it's going to be a reflection. So instead of looking like that, it'll look like that. Maybe not quite as curved, but you get the point. B affects the period. For tangent and cotangent, they have a period of pi. So because their period is pi, if you have a b value other than 1, you take pi divided by b in order to change that period. Okay, so first let's just look at some general examples. So if we have y equals 2 cosine of 3x, our amplitude would be 2. We would have a vertical stretch, which is why that pulls up the wave. So it's a vertical stretch, it makes it taller. And then our period we would find by taking 2 pi divided by our b value, and our b value is 3. So our period would be 2 pi over 3. So that's that one. This one, our a value is negative. That tells me a couple things. First of all, it would be a reflection over the x-axis. It's bigger than, the absolute value of A is greater than 1, so it's going to be a vertical stretch again, which means my wavelengths are going to be taller because my amplitude will be 2. So the amplitude is always going to be the absolute value of that A value. And for vertical stretch, you look at the absolute value as well. The negative reflects it over the x. And then we have a b of 1/4. So for sine, it's 2 pi divided by b. If you take 2 pi and divide it by 1/4, that's the same thing as multiplying it by the 4/1. So you would have a period of 8 pi. So this would really shrink down those wavelengths and elongate them, because you're going to have one cycle and it's going to take an entire 8 pi just to make one cycle. That's like going around the circle 4 times before you complete one full wavelength. Looking at a couple tangent or a tangent function, the 1/2, the negative first is going to be a reflection again over the x, and then the a equals absolute value of a is 1/2 is going to be a vertical shrink. We don't refer to that as a amplitude because the tangent isn't a wavelength. So we just do -1/2 for our a value. And then we find our period by just doing pi divided by our b value. Our b value is inside the function. And so for this one, it would be pi divided by 2. Our a value for this one is 4. And that would be a vertical stretch because it is 4 is greater than 1. And then for the period, for cosecant, it's the same as sine. And so 2 pi over b. So 2 pi divided by 1/2, or 2 pi times 2 be 4 pi. Which again is going to be those really elongated waves. Okay, so let's practice graphing one. So first I'm going to identify my amplitude. So I have an amplitude of 4, so it's going to have a vertical stretch. The period I'm going to find by taking 2 pi divided by b because it's sine, so 2 pi divided by pi, or divided by 2 is going to be pi. And then my x scale. So what that means is typically we complete one full cycle. I'm going to use my unit circle here in 2 pi radians. And so the sine function, if you start, we're just going to use our, this would be the point 1, 0, 0, 1, -1, 0, and 0, -1. So typically sine makes one full rotation in 2 pi radians. And so typically this one is pi over 2, pi, 3 pi over 2, then back to 2 pi. But this time my period is being divided by 2. So I'm going to take all of my period pieces and divide them by 2, which if I have a fraction, I'm going to multiply them by 1/2. Multiply them by 1/2, and these are going to be my new period pieces. So I'm going to end, my cycle is going to start at 0, and I'm going to end at, so then I'm going to go to pi over 4, and then pi over 2, and then 3 pi over 4, and then pi. Another way to think about that is you know that you're going to have your x scale is going to be counting by 1/4 times your period. So if your period is pi, we're counting by 1/4 pi. And we always start at 0 degrees and then we go to our end. So we start at 0 and then we work our way around. So I'm counting by 1/4, so essentially. So 0, 1/4, 1/2, 3/4, 4/4. And I did that because I cut my period by 2. Okay, now to find my values for sine at these places, I'm looking at the y coordinates. Remember on my unit circle, it goes cosine, sine values. So I'm going to look at my y values. So sine is going to go from 0 to 1 to 0, back to -1, back to 0. So I'm going to go 0, 1, 0, -1, 0. That's my parent function. Now my amplitude changed by 4. So this is going to be my AY column. So I'm going to multiply all of these by 4. So 0, 4, 0, -4, 0. And then I'm graphing the inside. So I'm going to sketch a graph of this. So I have my period of pi here, halfway, and then cut it into fourths. So I'm counting by pi over 4. So pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and pi. And then my amplitude was 4, so I'm going to need to go up to 4, and then I'm going to need to go down to -4. And then I'm graphing this 0, 0, sine starts at 0, 0. And then pi over 4, 4, then pi over 2, 0, 3 pi over 4, -4, back to pi. And then this is periodic, so it would continue like this, and I could continue counting by fourths, and I could even go to the negatives too. It's periodic, so now down it would continue down here, and then it would curve back up. So it's going to make those wavelengths. But if you can graph one cycle of it, then you could continue it infinitely. All right, let's try another one. So cosine, -2 cosine of 1/2 x. So our amplitude is going to be 2 because that's going to be our absolute value of our A. The A being -2 is going to do two things. It's going to be a vertical stretch, which means our wavelengths are going to be taller, and then it's also going to be a reflection. So one cycle of cosine typically looks like cosine starts at 1, and then it goes to 0, then to -1, then to 0, then back to 1. That's our typical parent function of cosine. So this one will be a reflection of that, so it'll end up opening up essentially instead of down. Our period here is going to be 2 pi divided by 1/2, which is going to be 4 pi, which means we're going to end at 4 pi. So when we think about our points around our unit circle, 4 pi is going to be our ending. So if we take 4 pi and divide it into 4 equal pieces, so we're going to cut it into fourths, that means that we're going to be counting by single pies. So to get back here, that means this is going to be pi, 2 pi, 3 pi, 4 pi. We're still going to consider that we have a unit circle, so 1 unit away on each axis. So 1, 0, 0, 1, -1, 0, 0, -1. But for cosine, those are our x coordinates on our unit circle, because it's an adjacent side, so it's going to start at 1, 0, -1, 0, back to 1. And that's what I drew here, 1, 0, -1, 0, 1. So that's our typical cosine values. So we're starting at 0, and then pi, 2 pi, 3 pi, 4 pi. And then we're at 1, 0, -1, 0, back to 1. But our amplitude is 2 and we're negative, so we're going to have a reflection. So you're going to take this column and times it by -2. So -2, 0, +2, 0, -2. Graphing the first and last. So I'm going to do a couple cycles here because it's easy to count by pies. So pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and 8 pi. My amplitude was 2, so 2, -2, and then cosine starts at, typically cosine starts at 1. This one has a reflection and an amplitude change, so now we're going to be reflected, and we have increased our wavelength, so we're starting at -2. Then back to pi and 0, so pi, 0. And then we go to 2 pi to +2, so right here. And then 3 pi to 0. Then 4 pi back down to -2. And then from there, I'd start over. If I wanted to do another cycle, I would just start back over here. So I would start back over, well, I would have to go back up to 0 first. So I'd go back to 0 and then back up to 2 pi and then 0. So I would follow the same cycle. So this would be one full period, and then here it would continue.
Mrs. Anderson?
Yes?
Can you dismiss Carson, Keith, and Bernstein to leave?
They already left.
They already left?
Wait. Case and who?
Bernstein?
Let me check here. Yeah, he's not in,
Is he in there?
he's not in here.
Thank you.
Sorry about that. Okay. We're going to do one more here and then tangent. So I know this is getting a little bit long, but this is a secant. In order to graph secant, I always graph its reciprocal function first. So I'm going to graph cosine, and I'm going to graph 2 cosine of 1/2 x. And then I'm going to use that to graph secant. So this one's going to actually not have an amplitude because it's secant, but my a value is 2, and I'm going to use that to help me graph the cosine. Period is going to be 2 pi divided by b since it's a cosine function. So 2 pi divided by a half is going to give me 4 pi. So we've done this one before. If we take 4 pi and we divide it into fourths, we're going to get an x scale of pi, which means you're counting by pi's all the way around, because one full cycle you're going to get back to 4 pi. So we got 0 pi, you got to remember to start at 0 and then back. 2 pi, 3 pi, 4 pi. And once you get good at this, you don't necessarily need the table, and then remembering that secant goes with cosine, I'm going to look at the x coordinates. So 1, 0, 0, 1, negative 1, 0, 0, negative 1. So starting at 1, then 0, then negative 1, 0, back to 1 because secant goes with cosine. So I'm looking at the x coordinates all the way around, and I'm going, it would be counterclockwise, and then multiplying these by 2, so 0, 2, negative 2, 0, 2. So throwing that on my graph, I'm going to do it like this: pi, 2 pi, 3 pi, 4 pi, negative pi, etc. And then I need to go up to 2 again. So since I'm going to graph cosine first, I'm going to do this as just a dashed line. So I'm going to graph 0, 2, and then pi 0, and then 2 pi negative 2, 3 pi 0, and 4 pi as 2. Change it to unverified. Okay, so and then this one would be down here. So I'm going to leave this just as a dashed line. Then I need to remember that, and then at 4 pi I was back up to 2. And then technically it would continue on, so forth. Then I remember that secant is the reciprocal of cosine. And anytime I take the reciprocal of 0, I would get 1 over 0, so I would be undefined. So anytime that cosine is equal to 0, my function would be undefined. And then, so I'm going to have and those are going to be my asymptotes. So at pi, at 3 pi, at this one. Now, when I go back to my original function here, and I take the reciprocal of 1, I'm still going to get 1. So these values are going to stay the same. The reciprocal of negative 1 is still going to be negative 1 times 2. The reciprocal of 1 is still 1 times 2. So the rest of the values stay the same, which means where I put the other dots, those are going to be the points for my next graph. This one's going to have another asymptote. Now you're going to use your asymptotes to guide your lines for your secant graph. It's going to go in the reverse way as the original. So if the cosine graph went like this during this section, the secant graph will be opposite. So this one will use those asymptote lines, or those invisible lines the function will get really close to but not cross. And so this one's going to go down here, and then this one's going to go back up. There's a formula to get those asymptote equations, but I like to do it this way because it seems to make the most sense. All right, I know this is getting long. I'm going to do one more. We're going to graph a tangent. So for tangent, I don't have an amplitude again because it's not a wavelength, so I can just identify my a value as negative 1, which means there's no vertical transformation, like no stretch or shrink, because a is the standard a value, but it does have a reflection. So typically tangent is going to look like this, and this one's going to be reflected. And then my period is going to be, it's going to be pi over b for tangent. And so I'm going to do pi over pi, which is going to be a period of 1. Now, we have to remember that tangent is sine over cosine. And so for tangent, if we look at these values, so 1, 0, 0, 1, negative 1, 0, 0, negative 1. So tangent's going to be undefined anytime your denominator is equal to 0. So tangent's going to be undefined anytime cosine is equal to 0 or your x coordinates equal to 0. So tangent's undefined at negative 90 degrees and positive 90 degrees. So when I graph tangent, I'm actually going to start here, and this is going to be my starting value, and then I'm going to be up here is going to be my ending value. So I'm actually going to do one full period on both sides of the 0 line. So this is 0. So I'm going to have 2 marks to the left and 2 marks to the right. And at these marks, turn that off. At these marks, those are going to be my asymptote lines, because tangent's going to be negative. Now typically that would be pi over 2 and negative pi over 2, negative 90 and positive 90, but I changed my periods. So this time, instead of making one full cycle, so this would be a total half a pi and half a pi, so the whole thing would be 1 pi, but instead I'm counting by ones. So, this whole distance is 1, so really this is just a half and a half. You can apply the same thing though if you wanted to find your x scale. You take the 1 and you divide it into fourths, and so really you're counting by force. So this would be 1/4, negative 1/4, negative 1/2. And so when I make my table, I think of it as negative 1/2, negative 1/4, 0, 1/4, 1/2. So now I'm going to have one full cycle, and it's going to be a period of 1. So 1 distance between that. So then my asymptotes for this cycle occur at x equals negative 1/2 and x equals 1/2. And so the equation for those asymptotes was above 2. So we can look back at that in a second. And then to get your y values, you're going to use the sine over cosine values. So you know that this is going to be 0 or undefined there. To find the ones in between, you're going to look at the 45-degree angle between, and you're going to remember that tangent of 45 degrees is equal to 1, because at 45 degrees it's square root of 2 over square root of 2. Square root of 2 over 2, and they're both the same. So tangent at that one is going to be 45 degrees. It's going to be 1. And then down here, tangent's going to be negative 1 because your x coordinate's positive, but your y coordinate's negative. And so at negative 1/2, it's going to be undefined. At 1/4, it's going to be negative 1. Back to 0 degrees, right here, you're going to have sine over cosine, which is going to be 0 over 1, so 0. And then up at 45 degrees, you're going to take your y value divided by your x value, you're going to get 1. And then up at the top, you're going to get 1 divided by 0, which is undefined. And so I have my asymptotes drawn at my undefined spot, and then my a value is negative 1, so this is going to flip it. This is still going to be undefined, this is going to be positive, this is going to be negative, this is still going to be undefined. So graphing, my asymptotes are drawn, then at negative 1/4, positive 1 right there, 0, 0, and then 1/4, negative 1 right here. And then you're going to go down like this. And then you would be able to repeat that. So that's one cycle. Now if you count it out to another force, it would repeat over and over like that. You could actually draw it maybe a little bit better. It's going to continue to approach those asymptotes. So I'm going to try to get closer and closer to those asymptotes. I drew it kind of spread out, but you get the idea. Tangent's hard, so that requires some practice. If you graph cotangent, you're going to want to graph it from cotangent. You're going to make a table from 0 to 180, because cotangent's going to be starting here and going to here, because cotangent is undefined at 0 and 180 degrees. So we'll have to look at that in class. And then there is the equation for tangent. You can find your vertical asymptotes by doing this formula as well, if you wanted to use that. All right,